Hey, Mr. Allred here. I have a second example of solving absolute value equations. This is a continuation of another video. But this is a new problem. It is the equation 6 times the absolute value of 1 minus 5x. And then subtract 9, that's equal to 57. So the first thing we talked about was isolating your absolute value. So our absolute value is being multiplied and it has something subtracted to it from it. So we're going to start off with saying isolate the absolute value. And so we're treating the absolute value just like it was a variable. So it has two things. We said it has a 6 multiplying it, so that 6 is a coefficient. But before that, it has this 9 here. So there's no fractions, there's no distributive property. All like terms on each side are collected because on the left there's 6 absolute values, and then there's negative 9 just regular numbers, so those can't combine. So we'll start off by moving the 9. So I'll add 9 to both sides. So that leads me to 6 absolute values of 1 minus 5x equal to, is this 66? Well, that's a good number considering what I see here. Okay, and I'm still trying to get that absolute value by itself, so don't jump ahead and try and solve it some weird way. So the next thing I can do is I can divide by the coefficient in front of the absolute value, which is 6. So I'll divide both sides by 6. That causes the left-hand side to reduce down to be just the absolute value of 1 minus 5x. And on the right-hand side, 11. Now I am ready to turn this into two cases, okay, because the absolute value is by itself. So we will create, I want a different color here. Change the color automatically. Create two cases. So keep in mind what we're saying is that what's in the absolute value bars might already be positive. So if what's in there was positive, we can just drop the bars. So that would leave us with 1 minus 5x equals 11. And I really like to go ahead and write down my second case so I don't forget about it. Okay. Case 2, I get to change everything inside the absolute value bars when I drop the bars. So this is assuming that what's in there was negative. So to make it positive, we change the sign. So 1 changes to negative 1, and negative 5x changes to positive 5x. But don't change both sides. Okay, just one. We're just changing the absolute value. There's no reason to change the 11. So now we will solve both sides just like regular linear equations in this case. So let's focus on case 1. So no fraction, no parentheses, like terms are already collected, so we're going to add, subtract. So I'll subtract 1 from both sides. So this gives me negative 5x equals 10, and then I will divide by the coefficient. So I'm solving these two things completely independent of each other. Oops, I forgot to change colors there. So in the end, I get x equals negative 2 after dividing both sides by negative 5. Okay, and we're going to check that solution out in a little bit. Maybe we're really confident about it, maybe not. But the other one solves very similar. I just need to add 1 to both sides. Okay. So now I have 5x equals 12. I'm going to divide both sides by the coefficient of 5. And I get x equals 12 fifths. Not a lot of fun to have a fraction that we're going to try and check. But let's see if we can make it work. So we've got negative 2 and 12 fifths. So let's go back up. Let's go back up and see if we can do our check. So we're going to go back to what our original equation was. 6 times the absolute value of 1 minus 5x minus 9 equals 57. So we're going to check case 1. We're going to let x be, was it 2? Negative 2. Okay. X be negative 2. I'm going to take a few liberties here. When I plug it in, that will be 6 times the absolute value of, it looks like 11, because negative 5 times negative 2 would be a positive 10. And then minus 9 equals 57. So the absolute value bars there, leave that 11, so we get 66 minus 9 equals 57, which is 57 equals 57. So that works out. So I'm going to come back over here and remind myself that the negative 2 works. And then I'm going to do the same thing with the 12/5. I don't really expect anything crazy to happen with the equations that we've got, but it's a good habit to get yourself into to be checking these. So I'm going to plug in 12/5 to my original equation. 6. 1 minus 5 times 12/5. The nice thing there is that the 5s cancel out, so I'll have 1 minus 12, so that'll be negative 11 in there. Okay, inside the absolute value, so I've still got minus 9 equals 57. So the absolute value of negative 11 becomes positive 11, so this becomes 66 when I multiply it by 6. So now we're at the same place we were a moment ago. It does work. Oop, I wrote the wrong thing down. Oop, looking for an eraser here. 57, 57, it does balance. So I can come back over here and say that the 12/5 did work. So we do get some practice in checking our answers here.